Hello, greetings fellow Stationeers, and welcome to part 14 of the Brutal Survival on Mimas. With me, 54 Bear. And yes, I have built a little tower. I am going to put a beacon up here. And that will be visible from further away. Also, it makes it a little bit easier to see from a distance. But today's task, or the task for this episode, is to get the CO2 cooled, because we're down to less than 2% in there. It is dropping fast because I got 15 plants. I don't really want to stop growing them because I do need to get the oxygen, and I don't like relying on oxide. So we are going to do a little bit of pipe shenanigans. And it's going to be the same kind of layout as we had before on the other side, just with a little bit less in the way of funkiness on the pipework, because the source of the heat is going to be here, and even though I'm going to be generating or using this to cool the stuff down, because I'm going to be using oxygen, the oxygen will freeze at about 150. So I do need to take steps to make certain that doesn't happen. Right, gas to gas. Yeah, we should. No, we are not good. There we go. Much better. So, yeah, going to be doing the same thing as before. I don't need to be carrying these around, so let's get these out of the way. Don't need that either. Pull those together. I do need digital valves. Don't need stairs. I need steel sheets. Okay, I think that's probably everything we need, apart from a lot of cable. Right, so won't reach from there. Oh, do need the wrench in the hand. Okay, swap the wrench for the flamey thing. Okay, that done. Right, so we will do this as before. We will connect the tank to one side and the cooling system to another. And I've just realized I don't have any pipe utilities, which I will need. Okay. Wrench. So let me just refresh my memory which way around the plumbing works best. Yeah, I think we'll take the cooling on the right side, which means we'll connect the tank to the left. So this will be a permanent connection. I'm not going to put any valves on it. I will, however, put a T-section, because I'm fairly certain I'll need to come off of this at some point in the future. Alright, then this one will just go up. Now I need a radiator. I'm pretty certain I have radiators down here. I have one radiator. Yeah, I did do the double stack the fuel. So yeah, as soon as this goes empty, just shut that off, open this up, and I can take the other tank off and fill it up and not worry about losing any production. Not that that's really that much of an issue anyway. Alright, so that's not the right kind of radiator. Bear, you are a doofus. That's the radiator. Oh, I've got 4 of these. I suppose I could put 2 on, but I don't think it actually makes any difference. I did do some testing on another world some while ago. Situation may be a little different now. Now I could just put it directly above. Doesn't have to be symmetrical. Maybe we'll do that. Okay, and I need a steel sheet and the flamey thing. Okay, right, we can do this and the straight. That will allow me to put a pipe analyzer on, which I do not have. Again, bad planning. I'm going to want to have a feeder on this, so I need a pressure regulator, which I also do not have, and a digital valve there. At least that I do have. That's the right way around. Yeah. So wire will come there. That will be good. Right, so I am going to need a pressure regulator and pipe utilities and a bottle full of oxygen. I'm also going to need to get power into all of this stuff, including the tank. So before we forget, we'll make this tank, or CO2 tank. Don't have to worry about naming that because I'm not accessing any volume pumps on the network. This will also need a name. DVCO2 cooler. Okay. There will be another digital valve added on the other side. I will need to set up a similar warming circuit as I did on the other side. So maybe we'll just put it there for now. Actually, that can be cheap pipe. Should it go up and around? Yeah, I think so. Okay, and the other digital valve will go here. This will control access to the warming side in case the coolant needs to be warmed up. And that also needs to get plumbed into the hot side. And the question is where? From here or from here? Now, I think we'll just take it sideways. Oops. Like that. Of course, none of this piping will work until it's painted the proper colour. Well, that's okay. Right, so all of that, both heat exchangers are connected to the hot side and sort of connected to the cooling side, but there's no gas in there yet. Right, I will need some more basic pipe as well. I mean, I could use insulated, but why waste it? See, do I have any? None up here. Oh, I have some down there, that's good. Right, so I want a pressure regulator. I'm fairly certain I have pipe utility. Yeah, down there. Okay. Grab that. Still haven't taken my nap yet. Let's go down and get the other things I need. Grab that. Oh, only 6. 9 there. That will be enough. 5 there. That's plenty. I don't think I need anything else. We'll just top up with that. And we'll grab some more cable. Now if I put the regulator here, I'm fairly certain I can get the cable past it. Yeah, just have to go like that. But that should have been a back pressure regulator, so I need to change that. Back pressure regulator. Cool. Let's do the pipe first to make it a little easier. Right way around? Yes. Okay, so need to get the other thing done. And the only way of getting this wire in is going around the houses. Actually, no, that's not true. I can just turn it around. Let's see. Put that there, that'll help it force to the right location. Also, I had already renamed it, so. Is that the right way?
Jetpack critical.
Alright, let's go get that taken care of. Whoa! In fact, once I get the CO2 cooled, I will probably use that as jetpack fuel as well. Right. So, yes, cabling. Data, of course, is on the other side, but no matter. Now we'll just go down here. Don't think so. Alright, so that hooks those up. Power, yes. Off, oh crap. Yeah, the code in the IC chip in there, it's controlling the digital valve here, just under this cross, that deals with the cooling, but because I didn't use the named batch method, it turns on all digital valves it sees. So I did rename that valve, but I need to modify the code. Alright, and I guess I should rename this one again. DVCO2 cooler. Right, pressure regulator does not need to be named, and this one, oh, DVCO2 cooler warmer. And yes, the oxymoronic naming convention persists. Right, to make it look neat, because as much as I like scruffy piping, I really prefer neat cabling wherever possible. We'll go like that. And again, I'm not going to connect that one until I've got the code modified.
Power critical.
And I have no spare battery. Oh, that's only processing 2 moles now. Where's my sniffer-matic? Right, so still got 1,000 moles in there. But nearly 10,000 in this one. So I could probably shut it off and just not worry about the rest of it. I mean, 10,000 moles of CO2 will last probably an entire gameplay, unless I get really, really silly with the other stuff. Right, I also need a bottle of oxygen, although I've got one here, so let's use this one, as it's handy. I can turn this on, set that to 0. Nope, don't want to turn this on until I can open that valve. And if I take it off, I'll have to rename it again, and I'm lazy. So, we shall hold off on that. Right, I came in here for a reason.
20 minutes later.
Why did I come in here? Modify the code. Right. Now the code that's in the laptop at the moment is the same as exists down there on the calling side. So that's this one. So I don't want that in this case, so I will import the code, put the chip back while I'm working, click on edit, and then pause the game in the background. Right. So, and immediately unpause it because I want to remind myself what name I chose for this. DV base cooler. Well, of course, that makes perfect sense. Right, so here we need to change this to a load batch name, and we need to give it the hash of DV base cooler. Okay, and that will work with that. And copy that, put that down here, and change that to the named variant as well. Right, that's all we need to do to keep the cooling working, or the base cooling working, in theory. Oh, need the chip in there first. in there. Export. No errors. Base temperature should be off, so that I believe is fine. Right, I will take the laptop with me just in case. What else did I need? Turn those on, fill that up. We've got the tank wired in. I think we're actually good. Oh. Duh. Yeah, I'll need to have a drink soon enough. Right, so I should be able to connect these digital valves now without any fear of them turning on when the base cooling comes on. Woo. Right, so I can turn that on manually, turn this on. It's a back pressure regulator. It should drain everything into there. Why is it not doing so? Oh, it is, just very slowly. Oh well, no worry. It's working. That's good. Okay, so that's going to be filling that up. So I do need to add these two to the mix. So this one should be, or it should show the same pressure. Interestingly, it doesn't. Oh, the pressure's going up. And of course, it is heating up a lot. But that's also going to be cooling this down. But that's not a problem. I never used this gas the way I was originally intending. My initial idea was I was going to do a lot of either degassing or smelting with it, but it never stayed hot enough really to do anything other than solder. Okay, yes, I'll modify the code out here just so that I don't have to run very far if I want to change the names. Right, so pipe analyzers. Oh, well, I only need the one actually. Yeah, because I can't read the temperature in there, in the pipes without it. Might as well put it on this side where it can be easily wired, and it will enhance the funkiness of the overall aesthetic. Right. I don't know that I need to give this a name, but I will anyway. CO2 cooler. All right. So that's really the end of the build, or
Hydration critical.
what I was going to be building today. The rest of this is likely to be IC coding, although it should be a lot of what we've already done. Right, I want to find the pipe analyzer. that is the hash. So we'll put that up here. Define analyzers as that. If I want, yes, that is the right thing. Okay, we'll define the low temperature limit as we did before, which we did at 160, I seem to recall. That's 160 degrees Kelvin. And we'll set up a memory variable for the tank temperature. So we'll just call it tank temp. And we'll put that in R14. I mean, to be honest, all of this is unnecessary. I could delete all of this, and anytime any of these are referenced in the code, I could just replace it with R0. I just do it this way to keep it simple for those who are interested in learning IC code and following along. Okay, so we will start with loading batch name from the, into tank temp, and I've already forgotten why I called the tank. That's why I was doing this out here. Close that. CO2 tank. How unimaginatively boring. Right. And let's pause the game in the background. Wrong bracket. CO2 tank. Nope. I need to define the tank as well. I'll just call it tank. Or tanks. Thanks for the memory. Alright, so small tank, small insulated. Not the kit. Excellent. Right. So load in the tank temp from tanks, the specific one being CO2 tank. I want the temperature. And it's batch method, so specify average. So if the I think we'll use 300, so we'll use max temp. So set greater than into device status. Remember, device status is the name of the variable I've chosen to use to control whether something is turned on or off. So if tank temp is greater than max temp, so that'll put a 1 into device status if the tank temperature is greater than 300 Kelvin. So that will do, and we will then store batch name because we want to set the digital valve, which I've called call valve. I wonder whether I should change that to digivalve. How many places will I have to change it? Here. Yeah, let's change it. Copy that. So call valve now appears in red everywhere. Makes it easy to find. There we go. Right, so little batch name, digivalve, hash, open quotes, and it is DVCO2 cooler. We want to set it on and set on to the value that is in device status. Right, so that'll get the CO2 cooling. Next, we need to check the temperature of the coolant gas. So again, we're using batch methods, using the named version. So set into, do I want to create another one? It'll be the last one. I mean, I could go down to R, no, I could go down, so yeah. Alias coolant temperature, and that goes into R15. There is no R16. There are 16 registers, but R0 is the first one. Right, so load into coolant temp from analyzers. And the hash for that was CO2 analyzer? I can't remember. CO2 cooler analyzer. Oh. And logic type we want is the temperature. Average. This time we want to see if it falls below a certain value. So store less than, again into device status. So we want to see if the coolant temperature is less than low temp limit. So if it is less than the lower temp limit, then the coolant needs to be warmed up. So we will copy this, but we will change the name of the digital valve to the CO2 cooler warmer, I think. And that should be all we need. Let me just check the name of that. DV CO2 cooler warmer. Okay, so that should be all we need. Okay, I am going to need to get rid of this god-awful buzzing sound. Finish that off. Lobsky. Right, and all of this runs on this code, or this chip. No error messages. Right, so that digital valve is on. So it's trying to cool the tank. That's good. Can I see the other one from here? Alright, so yeah, the coolant hasn't cooled down enough yet that it needs to be warmed up. So that is encouraging. Take this with me. Do the little cheaty wall hack thing. Have a bit more potato. Well, it says 0.54, so I thought it was 0.5% they needed. Right, let's... where's my... oh, there it is. Okay, so that was enough to get us by. I don't know how quickly this is going to cool down, but then I need a pressure regulator, or maybe just a volume pump, not certain which yet, to connect the tank to the hab, and then the same code in here, or the same chip, can have additional code modified that when the CO2 percentage falls below a certain threshold, it will open up the valve and it will pump CO2 in. But then I will probably need something that monitors the pressure in the base. Don't have anything in here at the moment. I'm monitoring pressure in this tank, and the pressure regulator is taking care of this side of it. Other than that, the pressure in the hab could go up to 250 kilopascals, and that chip in there wouldn't do a thing about it. Alright, let's finish the nosh. And we can turn that off. Okay, so we have a system for cooling the CO2. I'm going to go outside and monitor the temperatures just to make certain things look right. Close and lock, do it the right way around, and where's my paint can? I don't know where my paint can is. This could be a disaster. I may have to cancel the entire series if I can't paint anything anymore. This way around. Right, so temperature in here 567, 566, 565. So it's dropping about a degree a second. Coolant temperature is 229 on this side and 367 on this side. Interesting. Wonder if the efficiency or anything would be changed if I actually did make it into a loop. So I actually had a pump pumping it around. Because we've got one side of the radiator colder than the other. Oh, that might be something to play around with. I'm not going to do it on this setup because I need to get the CO2 cooled down in a hurry. And I could throw a couple of pipe radiators on here to potentially speed things up, but it wouldn't actually speed up that much. So, right, well, that is now empty. This can be turned off. And this can get returned to inside to be refilled. Anyway, I think we will leave it at that for now. We got a little bit done. Doesn't do much to the silhouette, but it's early days. We will keep adding to things and make the base look as funky as we can. Thanks for watching. Hope you found something useful and of interest. Like and subscribe, all that good stuff. And I'll see you in the next one. 54 Bear out.